Hi. Now we'll have another limit problem, and this is slightly, or I would say this is a bit difficult limit problem. So let's see if we can solve this problem. So here we have a limit of z to the third power plus z squared minus 5z plus 3 divided by z to the third power minus 3z plus 2 as z approaches 1. As you can see, it's a bit cannot readily factor this, both the numerator and denominator. So let's see, maybe, just maybe, it is defined at z is equal to 1. So let's see. So if we substitute z is equal to 1, it will be 1 to the third power plus 1 to the second power minus 5 multiplied by 1 plus 3 all over 1 to the third power minus 3 times 1 plus 2. So this is equal now to 1 plus 1 minus 5 plus 3 all over 1 minus 3 plus 2. So you have 1 plus 1 is 2, plus 3 is 5. 5 minus 5 will give you 0, all over 1 plus 2 will give you 3, plus negative 3 will give you 0. So 0 over 0, meaning it's indeterminate at z is equal to 1. So obviously it's not defined at z is equal to 1. So we have to solve it in a different way in that case. Now, since it's difficult to just to factor it, what we can do, we can try to divide it. We can divide the numerator by an assumed term, same as a denominator. So what we can do maybe is let's assume that z minus 1 is a factor of the numerator. Same case later in the denominator. So one way to factor it is to divide this term by, let's say, z minus 1. So to illustrate, you have here z cubed plus z squared minus 5z plus 3. That's divided by z minus 1. Well, we can do it this way, but it's a bit long. What we can do, let's use synthetic division. So synthetic division is, you have to make sure first of all that in your expression it's in descending order. All terms are there from the highest power to the lowest power. In this case, z to the third power, you have z squared, next is 5z, negative 5z, and then 3 multiplied by z raised to the 0 power. So all the terms are there, from the highest power, which is 3, to the lowest power, which is z to the 0. So if you recall in synthetic division, we can write it this way. So we'll write all the coefficients of the term, of the expression. You have 1 here, negative 5, and positive 3. So let's write it here. 1, 1, negative 5, and positive 3. And your divisor is z minus 1. So let's put 1 here. So 1 plus 0 will give you 1. 1 multiplied by 1 will give you 1 here. 1 plus 1 is 2. 2 times 1 will give you 2. 5 plus negative 2 will give you negative 3. Negative 3 divided by 1 is negative 3 here. So negative 3 plus 3 will give you 0. So therefore, since z cubed is your highest power, so here your quotient now will have z squared, which is one power lower than the highest power of your original expression, plus 2z minus 3. Take note that there is no remainder. Remainder is 0. So now, you can now express this expression as z squared plus 2z minus 3 multiplied by z minus 1. So this whole term, this whole numerator, can now be expressed as z squared plus 2z minus 3 multiplied by the quantity z minus 1. So let's remember this term. Let me just put orange color so we don't forget. So this is the numerator. Let's now try to simplify or to factor the denominator. You have here z cubed minus 3z plus 2. But it has to be descending order from the highest power, which is 3, until the lowest power, which is 0, which is z to the 0. You notice here you have z cubed, but you don't have z squared. So what do? You have to rewrite this now as z cubed plus 0z squared minus 3z plus 2. Okay? Now you have all the powers, z cubed, z to the third power, z to the second power, z to the first, and 2 times z to the 0 power. So now, using synthetic division, you have here 1, you have 0. So here 1, 0, negative 3, and 2. So 1, 0, negative 3, and 2. And then again, using z minus 1, you'll have here 1. So 1 plus 0 will give you 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 3 plus 1 will give you negative 2. Negative 2 times 1 will give you negative 2. Negative 2 plus 2 will give you 0. Now, this can be expressed now as, since this is z cubed, this one can be expressed now as 1 power lower, z squared, plus z using these coefficients, and then minus 2. Now, this is now the quotient. Now, we can therefore express this as z squared plus z minus 2 multiplied by z minus 1. So this is now your numerator, and this is your denominator. Now we have a numerator. We are able to express the numerator in a different form, as well as the denominator. We're able to factor it using synthetic division. Let's now put more space. Let's have more space here. Okay, now, so we can express now the numerator. Let me just try writing limit as z approaches 1. The numerator now is the one in the orange box. This is equal to z squared plus 2z minus 3 multiplied by z minus 1. This is now the numerator, divided by the denominator, which is z squared plus z minus 2 multiplied by z minus 1. Let me just Again, have some more space. Now, we can see here, we can cancel z minus 1 because it's in both in the numerator and denominator. And we can further factor now what remains of the numerator and what remains in the denominator. So we can write this as the limit. Let's factor the numerator. You have here z here and z here. So negative 3 may be what we can do. We can have, let's try plus 3 here. And let's try negative 1 here. Let's see if it works. So z times z, you'll have z squared. 3 times negative 1, you have negative 3. 3 times z is 3z plus z times negative 1, negative 1z. So 3z plus negative z, you'll get 2z. So it's correct. So divide this now by this expression, z squared plus z minus 2. Again, let's factor it. Let's just put here z approaches 1 before we forget. So we get z here and z here. Let's see, maybe we can put, let's see if z minus 1 works and plus 2 here. Let's check. Z times z is z squared. 2 times negative 1 will give negative 2. 2z multiplied by negative plus negative 1z, you'll get z. So 2z plus negative z will give you z. So here you can see we can cancel now z minus 1 over z minus 1. You have z minus 1 here. Again, also another z minus 1 here. So let's cancel it. Oh, now it looks a lot simpler. Imagine, from here, we now arrive all the way here. So let's rewrite the simplified expression. Limit of z plus 3 over z plus 2 as z approaches 1. Now, we can substitute now z equal to 1. So this was now equal to 1 plus 3 all over 1 plus 2. This is now equal to 1 plus 3 is 4 and 1 plus 2 is 3. So final answer, ladies and gentlemen, is 4 divided by 3. I hope you enjoyed this problem. It was a bit difficult, but we managed to solve it. See you in the next video.